My name is Patrick Cole, and my project and this presentation are about question answering using dynamic memory networks, first proposed by researchers at a company called MetaMind. This is an overview of the network that is shown in the figure. The network consists of four modules that are input, question, episodic memory, and answer. These modules are trained together and work together to reason over the input information, also called the story or context from which the answer is drawn. The most important module is the episodic memory module with its attention mechanism and memory update mechanism. More about that later. GloVe is an algorithm that converts words to vectors that represent the meaning of the word. Basically, the algorithm builds these word vectors by examining the word in context, and it determines the meaning of the word by examining the difference, often the Euclidean distance, between its word vector and other word vectors. The modules use these word vector embeddings to read the inputs and the questions. The modules in this paper use a GRU, which is a type of recurrent neural network designed to minimize the vanishing gradient problem that occurs in simple RNNs. The problem occurs because as the gradient is backpropagated, it becomes smaller and smaller and becomes too insignificant to change the weights of the network, hindering training. This problem is solved with the GRU's update and reset gates. The update gate updates the state of the network and maintains its memory, and the reset gate is used to forget non-essential information which it learns how to do through training. The network was trained using Facebook's BABI dataset. The dataset was introduced in the second paper I read, and you can see some of the examples of the tasks in the dataset. There are 20 different tasks in the dataset, but I only tested using task 1 as it is relatively simple compared to some of the higher level reasoning tasks. The dataset was created using a simulation with people, also known as actors, that can move around and interact with places and objects in the simulation, thus creating the stories about which we can ask questions. The goal of any question answering network is to be able to complete all 20 tasks in this dataset. The input module takes the context information needed to answer the question and outputs facts. Each word's vector representation from GloVe is passed to the GRU as the input. The fact representations are the state of the GRU at the end of each sentence. The question module is very similar, and the question representation is the state of the GRU at the end of the question. The episodic memory module, or EMM, is where the memory is maintained and the reasoning happens. Given fact representations from the input module, the EMM iterates over the facts and uses the attention mechanism to focus on the relevant information and the memory update mechanism to update memory accordingly. The number of passes over the fact representations represent the number of episodes, and more episodes generally increase the accuracy of the network. Here are the computations needed for each episode. Z represents a feature set with a fact representation C, the current memory M, and the question representation Q. Big G is the scoring function that assigns scalar scores to the information in the fact representations. Little g is the gating function from the scoring function. A modified GRU is used with the gating function, and the output of the final state of that GRU is the episode E. The episode is used alongside previous memory M to update the memory, and the final state of the memory after the last episode is given to the answer module. Here's another overview of the network. As you can see in the first episode, the attention is on John put down the football, but this fact does not contain the answer. In the second episode, the network knows to look for John and is able to find where he was when he put down the football. The answer module is fairly simple, using softmax over the memory output to determine the most likely answer based on the attention mechanism scores. The most likely answer is represented using a probability. My implementation was built using PyTorch and trained using the BABI dataset for task 1, single supporting facts. I used supervised training to, obviously, limit incorrect answers. The loss function was the cross-entropy error of the answer sequence. My implementation was ultimately unsuccessful as it seemingly chose random words from the input at its best. My theory is that this was caused by improper implementation of the attention mechanism due to the complexity of the computations. This concludes my presentation. Thank you for watching.